For the longest time I was thinking about BGP attributes which were not straight in my head. But I think after working a lot on this, it turned out to be simple and straight in the head eventually. So this is the list, my old paper 2015, BGP attributes, next hop, wait, local preference, locally originated AS path origin met neighbor type IGP, oldest route, router ID, shortest cluster ID, lowest IP address. Easy to find on internet this list of 13-14 attributes, but when I turn out to explain them with an example, it's not straight in the beginning. So this is where I'm creating this video, November 2016, how these attributes are straight in my head now and how they really actually work. This today I could get to this oldest route in the routing table and then the RID. So I could play with this, which proves and which I could see these turn out to be equal in this very simple topology of just 3 routers with 3 AS, 3 eBGP. So I have the lab running in GNS. I'm gonna explain myself how it is working. So this is the lab. Just to be sure, router 4 is not in this. The topmost portion is not in this BGP attributes labs. Only router 1, router 3, and router 2, 1, 2, 3, and they are advertising, of course, same prefix to router 3. So this is AS 100, 1 to 3, and between 2 and 3 is AS 102. They are sorry, AS is not straight. I took some previous lab. So they are advertising same prefix. Router 3 is making the decision, and based on that it is putting in the routing table. Now we will remain on router 3 for the prefix which is this is the prefix. So this particular prefix is being advertised by both the routers from their loopback, and right now router 3 is keeping 13, which means AS100, which says here AS100 is the top priority for him. This is the best. Why? Because this is the oldest route in the routing table, so that's why it's preferring this prefix. If we change the router ID, I change the router ID after this. It was this 23 was the best before. If we go up, we can see 23 was the best. We go up, we change the router ID, but because of the oldest route in the routing table, it's not taking 23 right now. So here it is, 23 was the best. Why? Because of the shortest router ID. Now I change the router ID to higher router ID, and what it become is 11012, it become 1112, and it took the best route, which makes sense. Now I change back to 1102, 1012, shorter than this router ID, but still it's not taking the best. So even router 3 has a lower router ID but not best. Why? Very simple, because of this is oldest in the routing table. If we go to this, we are somewhere here. So let me explain from the beginning what it is. So next hop is what we see here on router 3 is this is the next hop. Show IP BGP will explain very clearly what is next hop. So this is the next hop. This is the first attribute. If it's not in reachable, then it's not gonna put that in the BGP routing table. Second is the wait, Cisco proprietary. If it's not Cisco router, it goes locally originated. So keep that in mind. Router 3, any local originated has next hop as 0. So what does that mean? Any traffic destined to this prefix should just discard here. Another way is we can see the weight. So if weight is 32,768, means next hop should be 0 if it's default configuration, and destined traffic to these prefix should die just on the router, it should not go out. This is confusing if you are comparing these two. I don't know why Cisco has it, though there was already a prefix. Probably Cisco overset this local preference, but local preference is just for internal. If I have two router taking traffic from let's say my traffic is 2 egress and I want to give the prefer to 1 egress than other, then I'll put local preference on 1. So incoming or inside routers will prefer to egress 1 rather than egress 2. So even on router 3 we can easily see, if we do a route here, local preference is 100 by default for any route, for any prefix, for any neighbor, it doesn't change. Now this locally originate, this was a bit confusing. So locally originate and wait, they are close, like I said, is local originated by local router, is by network command, which we do use in the network in the BGP process, or by redistribution when we say redistributed connected or redistributed OSPF or static or summary routes. AS path is here in 3. This is the AS path. That's where we put AS prepend to show tester path. And in this lab, because they are just one hop away, for router 3, one hop here, one hop here, the prefix I'm advertising. So this is like one AS, one hop, which it shows here, just one hop. Origin is IGP, EGP, which is not in use, it's gone, and over incomplete when we redistribute static connected, whatever. So these are type 0, 1 and 2. 1 is we not gonna found anywhere. So origin can be seen at the end, and it shows here. So it says here origin in the BGP attributes. We see origin code, it says IGP. Very simple, because it's coming from that router. So router will believe if BGP peer is saying it's my IGP, so obviously router is gonna believe that. If eBGP, it will less believe, it's incomplete, means that 3 router, here we gonna see the question mark. If it's incomplete, means this prefix is coming to this router 3, from this neighbor, from this AS, but this AS don't know where the origin of this prefix, if we have question mark here, incomplete here. What does that mean is this prefix, this AS is learning from the source he don't know, maybe redistribution, maybe some from other side, but he has no idea. So if 2 AS coming with the same prefix and one is saying IGP, it's from my IGP, router will believe IGP, then eBGP or incomplete origin. MED is lower matrix, more preferred, simple, neighbor type. So by reaching here neighbor type, eBGP is always preferred over iBGP. What does that mean is, in the simple topology, if I advertise prefix on router 4 and router 3, they are IGP. This is internal 1AS, router 3 and 4. So if router 4 is advertising one prefix and router 3 is listening this prefix from IGP and from other eBGP neighbors, so he will believe eBGP, because BGP has been designed to take egress as soon as possible, hot potato policy. So it's always eBGP. That's where it's a neighbor type. IGP matrix, keep that in mind. IGP matrix is to next hop, not for anything else. So what does that mean is here, this is the next hop. So if this is, and I believe This is not for eBGP. This comes in picture when we have neighbor type is iBGP. So next hop to this, cost to this IGP matrix or cost to this. So this attribute is valid only when neighbor type is iBGP. So some attributes are not straight going in the flowchart, they are depend on other flow. For example, if is a non-Cisco, then wait is not there, and if Cisco wait is there, then locally originate will not come because that's already been decided. Same if we have neighbor type eBGP, then this next attribute is not in picture, is not in consideration, only when neighbor type is iBGP. Now for us, we are considering eBGP because based on our topology, next is oldest route in the routing table. That's where this lab is more clear to me when I am talking about these prefixes and these attributes. So if we look for particular prefix, though 102 means router 3, router 2 and 3 eBGP neighbor has lowest router ID. Still, what it is doing is it's taking router 1 this path as the best. Very simple reason, because after changing the router ID, this reset, if we go up, we can see that it reset the neighbor. Here 23 was reset. That's why if he took oldest route in the routing table, means this BGP neighbor is up. So if we do show IP BGP neighbor and include their uptime, so uptime is this 29, which is what is we can see uptime, this uptime is more, so that's why it's taking this as the prefix as a best. If we reset this neighbor, for sure is gonna take this one and it will never come back to this one. So this was the main purpose of this video, where I could got the clarity on oldest route in the routing table age, and it's not for IGP. Like I said, these attributes are not straight, these are different, depend upon the flowchart. So eBGP and neighbor stability, it says clearly longer a route in the routing table, more BGP process will accept that and believe that it's more stable circuit, more stable ISP. Router ID lowest is same what we played here. Router ID, these are the router ID we play. We cannot avoid BGP reset if we change the router ID. And then again this is coming shortest cluster list. This is when we have RR scenario, route reflector, otherwise this attributes doesn't come in picture. And obviously the last one is the lowest IP address. If we cannot have same two IP address in two eBGP neighbors update. So this list makes sense, but keep that in mind, it's not straight as per the flowchart as it looks like in 1 to 13 or 1 to 14. They are dependent. 2 or 3 are not very straight, especially oldest route, neighbor type and oldest route, and this shortest RR. So 3 are not straight, they have side flowchart. So that was the whole purpose of this video. Yes, there are some another way to classify well-known mandatory discretionary, where discretionary says router may understand, it may be present, it may not be present in the updates, but router will understand this. They are implemented in as per the RFC. But optional, maybe the router may understand it, router may not understand it, depend upon the vendor box. but well knowns it has to understand, discretionary mandatory has to understand, has to be present, otherwise it's not gonna be in the routing table. BGP speaker will discard that, and discretionary may be there, may not be there, but router is gonna read those fields. So that's all about it.